This video is an introduction to proportional and direct variation. A direct variation or proportional relationship is a special type of linear relationship that can be written in the form y equals kx. Okay, so first thing that's very important to know is that it needs to be a linear relationship. For something to be linear, that means when we do a table, delta y over delta x has to be the same. Okay, it means it has to make a straight line. That's one of the first requirements. Now, it says tables. First, you need to do is to figure out if the table is linear. Again, that is what is up here. Now, it says that if the table is not linear, then it is not proportional. Okay, so right there you can stop. If it's nonlinear, then it's non-proportional. To determine if a linear set of data is proportional, first you need to find the equation. If the equation has a constant other than 0, it is not proportional. So remember, we have y equals the coefficient times x plus or minus the constant. To be proportional, you can have y equals 2x, but the constant has to be plus 0. And see, a lot of times you won't see that plus 0. Okay, so this is linear and it is proportional. Now, if I were to go down here and maybe I had an example of an equation that was y equals 2x minus 3. First off, if you go through and put it in the calculator, this is linear. But because it has, right here it says minus 3, it is not proportional. Another type of example you could have, and again, you just need to ignore all this stuff on the side. We're going to come back to that in a minute. If you have something that is y equals, I don't know, 2x squared, right here, the first thing you would go through and do if you put in the calculator, you're going to find out that it is non-linear. If it is non-linear, it cannot be proportional. So it is not proportional. It has to be linear in order to be proportional. Okay, now let's go back and look at some of these real quick. Let me move up. Oh, come on. Kind of moving kind of slow here. There we go. So, let's see if I can get rid of this on my screen. So right here, what we're going to do, I'm going to find delta y, the change in y. This right here is plus 4.5. You can always find that by taking 6 minus 1.5. Right here, this is 1.5. This right here is 1.5. Then you have to find delta x, the change in x. This is 3. This is 1. And this is 1. Now, we don't know anything yet. We don't know if it's linear or proportional or anything. We have to go through and you have to find delta y over delta x. So if I take this right here, 4.5 over delta x, which is 3, and divide it, I get 1.5. The next one, I have 1.5 over 1. That is 1.5. Okay, well, since they are the same, this is linear. Now you need to find out if it's proportional. So there's not a whole lot of room, so I'm going to go ahead and expand my table out. Let me just get 1 and 1.5. Well, my coefficient is 1.5. 1.5 times 1. You multiply these two together, it gives me 1.5. So my equation would be y equals 1.5x. And even though it's this right here, if I wanted to, I could add a 0. Because of the plus 0, it is proportional. So that means that my k, because remember up here at the top, it says that in the form of y equals kx. Let's see here. Oh, let's try and get my pen here so I can move it down. There we go. I have y equals kx. Well, k equals 1.5. And we'll worry about what to do with that later. Right here, first thing you'll do is delta y. The change in y right here is minus 4. Right here is minus 2, minus 4. Delta x plus 2 plus 1 plus 2. Okay, first thing you want to do delta y over delta x. I get negative 4 divided by this number over here, which is 2. Negative 4 divided by 2 is negative 2. The next one, negative 2 over 1 is negative 2. Okay, since these are the same, it is linear. Okay, but now since we know it's linear, I have to figure out if it's proportional. So if I take negative 2 times 1, okay, you multiply these together and I get negative 2. What do you have to do to negative 2 to get to 1? You have to add 3. So my equation is y equals negative 2x plus 3. See how it has that plus 3? It is non-proportional. Okay, so looking at the equation, that's how you can tell. Now another way to do it is by looking at the function or equation. First off, what makes it proportional? It says if a linear equation or function has a constant other than 0, it's non-proportional. Well, here's what it means. When they say a constant other than 0, there's your constant, minus 6 plus 8. That's why it is non-proportional. Over here, this is the same as saying plus 0 plus 0. And because these are 0, it's proportional. Next, right here looking at a graph. If the graph of a linear function goes through 0, 0, it is proportional. So this one right here, see how it goes through 0, 0? That's why it's proportional. This one crossed down here on the y-axis. This is non-proportional. Now, if you look at these points in set notation, or if they're just giving you a list of points, put the points in the table as the first step. So I have x, then y. Remember that that's how they go here. X, then y, and so on. I've got 1, negative 4, 4, negative 16, 6, negative 24, 9, and negative 36. So the first thing I would do here, I'm going to go up here and do delta y. The change in y right here, I'm getting more negative, or you take negative 16 minus negative 14. That's negative 12. I'm getting more negative, so I'm going to subtract. Let's see, what is that? That's negative 12 as well. Delta x, the change right here is plus 3, plus 2, plus 3. Uh-oh. Right here I've got delta y over delta x. Negative 12 over 3 is negative 4. The next one, negative 12 over 2 is negative 6. These are not the same. This means it is not linear, so it's not proportional. It must be linear in order to be proportional. Okay, I'm going to erase this. Why don't you write this down in a table and see if you can figure out if it is linear and if it's proportional. So as I go here, I'm going to draw my table. I have x, then y, 1, 1, 3, 7, 5, 13, 7, 19. Okay, so right here, I'm going to do delta y. I have plus 6, plus 6, plus 6. Delta x, plus 2, plus 2, plus 2. Right here, delta y over delta x. I have 6 over 2 on all of them, and they are 3. That's 3 when you divide it. This is linear. Now we need to figure out if it's proportional. So I have 3 times 1. Okay, so you multiply those together. And what do you have to do to get 1? I have to subtract 2. My equation is y equals 3x minus 2. Because there is a minus 2, it is non-proportional. Here's the next one. Michael is ordering t-shirts for the Wake Breakers Club. The total cost of the t-shirts varies directly. That is very important. This is going to tell you that it's proportional. It's going to tell you that the constant is 0. And they want to know how much. It says 25 shirts cost $400. So they want you to figure out, it says complete the table and write an equation that represents the total cost in terms of the number of shirts. We know that 25 shirts equals $400. Well, how much does one shirt cost? It's right here. So if I take 400 and divide it by 25, that's 16. So one shirt is 16, 2 shirts is 32, then we have 48 and 64. Well, what's happening each time, each shirt, I'm increasing by 16. It varies directly. My equation is y equals 16x, because all I have to do is take 16 times the number of shirts. See how the constant is 0? It's proportional. So let's talk about this real quick. To be linear, all that means, because this is where people get them confused on the tests and quizzes, it means that it makes a line. It means that it makes a straight line. That there is a consistent, how about I put same, rate of change. I'm saying that delta y divided by delta x is the same. That's all that linear means. That's all that being linear means right now. And so the next thing is, we're talking about today proportional. Okay? To be proportional, the first thing it has to do, it has to be linear. Then the next thing that it has to have is the constant has to be 0. Okay? So it must go through, on a graph, it must go through the origin, which is 0, 0.